monitoring thing done on in AP Classroom. Remember, College Board, it was due last night. I will put those grades in for you. Oh, hi, Jacob. I just responded to you. Welcome back. If I need to extend yours, let me know, okay? So we'll talk. Also, that's where your quiz is. So I've talked about the quiz every day. I don't want to waste your time with it anymore. But if you were still unsure about where the quiz is, please talk to me. Don't wait till Tuesday or Wednesday and like, I never knew where it was, okay, or how to do it and all that stuff. So talk to me about it if you have questions when we're done with the notes. And you have no school Monday, right? That's nice for you. I do. But we'll be working on the new material today, tomorrow, Tuesday, and then a work day next Wednesday, all right? Now, let's get started on this. So what's kind of nice about today is we're still working on rational functions. That's the good news. The bad news is we're still working on rational functions, right? We don't love these. They're not our favorite thing to do, maybe. I don't think, anyway. But it should be getting easier as we're doing it every day. And so what are we doing today, you might wonder, if we're doing the same thing? Well, we're doing the same thing we've been doing day after day and adding to it. One step in this problem and then a different step in the second problem. So we have 2 examples to do and short homework, okay? So especially if you're struggling still with any of the parts of the rational function, intercepts, HAs, VAs, all that stuff, we're doing it together, 2 more of them right now, okay? And so let's just start with what we know. And that's what, by the way, these steps are telling you. These are all the steps that we've been doing with 2 new ones. This is the first new one, and this is the second new one, so I'll come back to those. But everything else is like factor, cancel, holes, asymptotes, intercepts, graph, okay? So just maybe a different order, a different language than what we've been using, but the same idea. So here we are given a rational function in standard form, okay? That's what that means. It's in standard form. We're going to get it to factored form. That's always our first step. And upon looking at this rational function, I see that the numerator and the denominator are both chart problems, but the easy chart problems. However you need to find your factors when you're doing this on your own, go ahead, but the 2 numbers that multiply to get 12 and add to get 7 are 3 and 4, 4 and 3, whatever order, right? And then the 2 numbers that multiply to get -6 and add to get 1 would be -2 and 3. So I mean, do the signs matter? Can I give the 3 the negative if I want to? No. Okay, just making a point, right? So it does matter who's negative, right? We have to make a positive one. Just want to throw that out. Okay, standard form, factored form, okay? Now we can look at this and say what x can't be. X can't be 2, and x can't be -3. Remember, anything that makes your denominator 0 is an excluded, restricted from our domain, right? Just the denominator. And now we can simplify this. We can rewrite this as cancel, cancel, x plus 4 on top, x minus 2 on bottom, right? So standard form, factored form, simplified form. Because there's a day later on where it's like write your answer in both, I think it's tomorrow, write your answer in standard form and factored form. That's what that means, okay? And that'll make more sense tomorrow, but that's why I'm pointing it out. All right, so now we can start pulling out all of our information. We usually start with the whole because a whole comes from whatever you canceled, right? So we canceled out the 3. So x equals -3, we'll use that for the x value of our whole. Remember, a whole is a point, an xy. It's just an open point because it's being excluded, all right? But it's just an ordered pair. So I need the y value. So I'm going to plug in -3 for x. On top, I get 1. On bottom, I get -5. So that's -1 thing. That's where my whole will be. Anything left over in the denominator is a vertical asymptote. So x equals 2. Didn't cancel. So that was his job. Remember, both numbers in the denominator that are bad have to be one or the other. Okay, then we can do an HA. Where do we get our HA from? The degrees of our numerator and denominator. Any form is fine. Let's just look at this one since it's right here. 1 over 1. Remember, when the degrees are the same, we then look at A over B, which are the coefficients on top and bottom. So 1 over 1 equals 1. And hey, always a y. Don't just write 1, don't just write 2. X equals 2, y equals 1. That's A. Then let's do our intercepts. X-intercepts, so this was the number one question I got yesterday. Think about it. We've used every single part of this problem except the x plus 4, right? The x plus 3's canceled, became a whole. The x minus 2 became x equals 2 and became a VA. All that's left is this x in the numerator, and that's what your x-intercept is. Any x left in the numerator. So x plus 4, set it equal to 0 and solve, I get negative 4. And you could write it like that, or you could write it as an ordered pair. You would see it both ways. Either way, doesn't matter, okay? Y-intercept, when x is 0, y is what? So remember, intercepts are always where the other letter is 0. So I'm just doing this same type of problem, except I don't want to know negative 3. That was the whole. I want to know what y is when x is 0. So I'm going to just plug it in right here. 0 plus 4. 0 minus 2, I get 4 over negative 2, which is negative 2. Or you could write it like this. I try to give you as much information as I can about how you could see things because I don't have 100% control over what you see. When it's a non-EOC class or a non-AP class, I would make every test, I would make every exam, and I could say, I'm always going to make it like this, guys, you know. But you could see intercepts written either way. So I just want you guys to be aware of that. And when I say that, I don't care which way you would write it. Just know you could see it either way on any kind of test, okay? So that's everything that we've learned. Let's go with step 6, though. If you look up at step 6, I'm going to throw this in. This is one of those situations, though, I'm going to be honest with you. If I were teaching this last year, I might talk about it, but I don't really require my students to find symmetry in rational functions because it very rarely helps us with the graph. And you're going to see that. We're going to find the symmetry in the two that we're doing, and both of them are going to have none. So it's like doing all this work that really we didn't need. But it's good to talk about because it's the same symmetry as you just had with polynomials. And it's right here. When you plug in a negative x or a negative number, what you're looking to see is, do all of the signs stay the same or do all signs change? That's what that notation means. And when all the signs stay the same, it's even symmetry. Even symmetry, also known as y-axis symmetry, is where the left side and the right side are identical twins on either side of the y-axis. That's even, okay? Odd is origin, odd. Your graph has to go through 0, 0. So the minute it doesn't, you know it can't be that. And then diagonal quadrants are the same. You're going to see very quickly that the symmetry is none here, but let me show you the math of it. Technically, you would plug in a negative x everywhere there's an x. But I'm going to show you why you don't really have to do this much work. Let's just show it first. So to test for symmetry, I'm typing in a negative x and plugging in negative x for every x. And I'm going to simplify it. And remember what I'm looking for. Once I simplify this, all signs are the same or all signs change. Immediately, without even doing this work, I could have just looked at it. I know that this is going to stay the same, right? When you square a negative, you get a positive. So the original and this one stayed the same. Yes. In the next one, 7x is positive, but what happens here? It becomes negative. So it changed. Before I go any further and waste my time or your time, I'm already none, right? Because if we already have one that stayed the same, one term stayed the same, one term that changed. You can't have a mixture in the same problem. It's either all stay the same or all change. And so just by figuring out those first two. And I could have done that just looking at these two, maybe. Maybe you need to write it out. It's up to you. But that would tell us that there's none. There is no special symmetry in this. Okay? 99% of the time, it's none anyway, so there's really no need to do it, but I wanted to expose you to it again, okay, what symmetry means. Let's graph what we have. Let's graph it. So I'm going to start with my asymptotes, vertical at x equals 2, horizontal at y equals 1. Okay, so that's these two. I have a hole at this ordered pair. So left 3, down a fifth, that's just down less than 1. Okay, so left 3 down just a tiny bit, because these do not have to be perfect. It's very rough. The lines are tiny and they give us way too many decimals. Okay, but it's an ordered pair, open circle, hole. Okay, x-intercept at -4, and a y-intercept at -2. Okay, so if you remember from the other day, we learned that we are going to be kept in these little corners, like quadrants, marked by the red lines for me. And we know now that there is one of our 2 branches in this quadrant, just by the points that they gave us. And we also know, I think, that we should also have a branch on the other side of this asymptote. So we make a very simple XY chart and plug one value in. That's all I require. And that would be one number to the right of this, like 3. But really any number is fine. And one more time using that simplified, in all that work up there, I'm going to plug in 3 and find y. So I get 7 over 1, or 7. What does that tell me? It tells me which one of these corners or quadrants this final branch would be in. To the right 3, up 7, so here. And you don't need any more. That's enough to know, again, how rough these are, but where your branches are. If I had gotten like -2, then it would have been down here, and they would have been side by side. That's why we only need to pick one point. That y value that we get tells us if we're going to be up here or down here. Okay? We good on this one? Are these getting easier? Harry says no. Yes. Yes. How do I know? Wait, say it again. Oh, okay. So her question is, how did I know the whole is -3 and not the 2? Okay? It's because if you cancel your whole, that's it. The one that cancels is a whole. Anything that's left in the denominator is a VA. Okay? And you're going to see it again in this final example. Okay, so we don't have to flip back. We're going to go to example 3, but let me just tell you, step 7 is having us do this new thing. It's really, really important on recording. And I'll tell you why I think it's good. But we're going to do it. So determine whether the graph lies above or below the x-axis using the zeros from step 3 and step 4 to blah, 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 blah. Okay, this is going to look kind of familiar because, oh, thank you, Sadie. I didn't even hear it. Sorry, were you waiting long? I'm so sorry. I didn't hear it. Okay, so we're going to start out doing exactly what we just did. But just to kind of move things along, I'm not going to work out this factoring problem. We've done one yesterday, we did one the day before with the 2 in front. If you still need help with this, you need to find some time with me, okay? But when you factor this with the extra steps of bring down the outside 2, split the middle kind of method, that is what the factors would be. I just didn't show the work, okay? In the denominator, I have x plus 2, x minus 2 for the difference of 2 squares. So always, first step is factoring. So we have standard form, factored form. Then we look at our denominator and we say, what would make our denominator 0? Those numbers are bad. Right? Again, just the denominator. is where we get these numbers. So first thing we look for is a whole, right? Because we're going to cancel to find the whole. What cancels? Nothing. Guess what? We don't have a whole. You don't have to. You might have holes and no VAs. You might have VAs and no holes. Okay, there's no rule about that. Just know what you do to get them. You cancel to get a whole. Nothing in the denominator will cancel with anything in the numerator, so we don't have a whole. What we do have is 2 VAs. Because remember the definition, anything left over in your denominator is a vertical asymptote. Well, we've got 2 x's left in our denominator. We will have a VA at 2 and a VA at negative 2. Could you have written plus or minus? Yes, you could have. Okay? So that takes care of that. We don't have a simplified version in this case because nothing cancels. We have a factored version and a standard version. All right, let's keep going. We would want to find the HA. We use the degree of the numerator, degree of the denominator to find that. I think this one's easier to look at. 2 over 2. Again, they're the same. Whenever they're the same, we look at the coefficient. So 2 over 1, which is 2. Again, don't forget, that's K. And x-intercept and y-intercept. Remember, x-intercept are any x's left in the numerator. Let's look what's in our numerator. Both of those. So we have 2 x-intercepts. That's okay. So when I set x plus 1 equal to 0 and solve it, I get negative 1. When I set 2x minus 5 equal to 0, I get 5 halves, also known as 2.5. You could put it in your calculator and find that if you wanted. And the only reason I'm writing that is because I'm going to have to graph in a second. What's 5 halves? I don't know, but 2.5, I know where that is on a graph, so I'm just putting that there. Okay, so remember, x-intercepts, any x's left in the numerator. All of them are left in the numerator because nothing canceled, so we happen to have 2. Y-intercept is plug in 0 for x and solve for y. So think about that, guys. If I plug in a 0, you can use either one, by the way, this one or this one. You don't even need to show any work, really. When you plug a 0 in here, when you plug a 0 in right here, this whole thing becomes 0. When you plug a 0 in here, that becomes 0. So you have 0 minus 5. You're always just left with the constant on top. So when I plug in 0, I'll end up with negative 5 on top, and plug a 0 in there, I would have negative 4 on the bottom, which is just positive 5/4, also known as 1 and 1.25. Okay? So you could show all the work, put it in your calculator, but just remember, try to find places that you can do shortcuts. We do enough work in this class, right? Find some places like, oh, that makes sense. If I plug 0 in here, 0 in here, I'm just left with the constant. Same thing in the denominator, okay? But you could have plugged it in either place, calculator, show all the work, do it in your head, whatever makes you happy. And then let's add in our new guy, symmetry. And again, you could do the whole work where you're, I guess I should have made that an R. You could do like where I did on the last example where you plug in the negative x, but if you just start doing it, if you just start without having to do a whole bunch of work, if I do just the first 2, I can immediately see that this is none again. Okay, I would probably do this in my head, but because I know when I square a negative here, I'm just going to be left with the same exact thing, positive. So that's a same, they stayed the same. But when I plug a negative x with the negative 3, that becomes positive 3x. Stayed the same, changed. It's got to be all or nothing. There's no reason to keep going with the rest of the problem. Who cares what happens with the rest of them? We already ruined our chances of being all change sign or all stay the same. Okay? That's everything we've learned. You might notice there's this little weird looking thing over here. Let's graph what we have first, then I will explain this last concept to you. Okay? So again, graph our asymptotes first. We happen to have 2 in this graph. Okay. We have a positive 2 for our horizontal asymptote. So this looks different than all the ones we've done this week, right? Vertically, we have 3 sections, right? Think about it. We have 1, 2, 3. And what happens with all of these graphs is you will have a branch in every vertical section. So we should have a branch either here or here, one or the other, that vertical section. We should have something in the middle. I'll tell you what those could look like because that's the new part. And then you should have a branch either here or here. So if I took out this middle part, it's almost exactly like the other ones. You're either going to be side by side or diagonal with those same looking branches we've done. But the middle one could have one of two things, and that's what makes they think this is the good thing to do. I'll explain in a second. But what can happen in the middle is I could have like a parabola looking kind of graph where it goes up and turns around, or it could be up here, or it could actually look like a cubic, which kind of looks like an S. And those actually go right through your horizontal asymptote. So horizontal asymptotes are kind of an exception to the rule. You can touch or cross horizontal asymptotes. You can't with vertical, but you can with horizontal. And you're going to see that happen in this graph. Okay, so we'll come back to what the graph is going to look like. Let's just finish putting all these intercepts on here and see what we can make of what we have so far. So x is -1. We have an x-intercept there. And at 2.5, right, approximately there. And at a y-intercept at 1.25, so like, I don't know, about there. That's all we have. But what this does tell me is where one branch for sure is, 1/3 of my graph. Because remember, one has to be either up here or down here. And I know, oh, I didn't mean to make that look like a box, but it's curvy, okay? Just like in the other ones, now I know the right side of the graph, there's nothing else over there, okay? Something's going to happen in the middle. Something started here, but there's not enough information to know if this is going to be like a parabola-looking graph or like a curvy graph that goes through. And then I also need to know what's going over here. So let me just give you a little piece of information. What I would do in this situation and what I would encourage you guys to do on a test, because I will not put this on a test, I'm just explaining to you this concept, okay, is you would make your XY chart. You would just pick more than one number in this case because we have two sections. Like I would definitely have to pick something over here. So like to the left of my -2, I would use -3. That would take care of the second of 2/3, right? I would get my point over here, either here or here, just like we did it with all the others. And then in the middle, I would probably pick a few more points. I need to know, is this going to go, I need to know what's happening here. Is it going to turn around and go back down, or is it going to go up? So I might want to know what's happening maybe at 1 and see if that gives me enough information. And I might have to pick some more, but I would always start with the least amount of work and build onto it. Okay, so hold that thought, because that's what I would say to you on a test or a quiz would be what you would do. So it's very similar to what we've been doing. This idea is going back to something we've already learned, which is testing intervals of our x-axis to see what parts of our graph are above and below. This is a lot of work. I'm not going to make it a lot of work. I'm going to give you the answers, but I'm going to explain it to you. So what I would say to you is, and I'm running out of room, is you would want to pick out all the important x values that you have over here. And I'm going to explain how to find those. Important x values. Because that's where stuff changes, right? To the left of this, in the middle, and to the right. So we're usually looking at our vertical asymptotes. What's happening to the left and right? So some important x values that we have are 2 and -2. There's asymptotes there. Those are pretty important. Horizontal asymptote, that doesn't have anything to do with the x-axis. Oh, x-intercepts, -1 and 2.5. I'm going to use 2.5. And we always throw in 0. Always, because it's in the middle, and we're still wanting to know what's happening in the middle. Although we already know, all right, because we found the y-intercept. But this is just what they do, okay? Now, those are all my important x values. Remember, the next step is to put them on here, least to greatest, okay? So -2, -1, 0, 2, 2.5. That's a lot of numbers. Think about how many intervals they are, because if you remember, the next step is to pick a number to the left of -2, in between these, in between, and to the right. There are 6 things they want us to find. We're not going to, don't worry, but what we're doing right here, we have seen before, so I think it's valid to go over it again. So I'm going to pick a number to the left of -2, like -3. Look familiar? We would have done that in our XY chart anyway. Pick a number in between -1 and 2. I used -1.5. And so on. A number in between -1 and 0 is -0.5. Between 0 and 2 is 1. Between 2 and 2.5, yuck, 2.25 would be a good one. And then to the right of 2.5 is 3. Think about how much work this is when we would have just used -3 and 1. They're in there. No, this is a lot more work than needs to be done. But let's just go ahead and talk about it. One more minute. I'm almost done. So we're going to test all of these points hypothetically. We're just going to do one right now. We're going to take our test point and plug it back in. You can plug it into either one. I just think this one's easier. So you can just watch me do it unless you want to do it with me. So I'm going to use my test point of -3 and plug it in. So 2 times -3 to the second power minus 3 times -3 minus 5. So I just typed in the numerator. Enter. Leave it there. Then in the denominator, -3 squared is 9, or if you didn't know that, you can type it in, minus 4. There's my denominator. 22/5, I could write that, but I'm going to write it as a decimal, 22/5, 4.4, okay? And what you would hypothetically do is go through each of these and plug them in. It took me literally like more than 5 minutes to do. And I'm pretty fast on the calculator, right? So you can imagine it could take a while. Let me give you these answers. Steal them from me. You could write a decimal. You could write a fraction. We are doing a rough graph anyway. These numbers do not have to be perfect. It's really more about the signs. But just trust me, I did all that work for us, plugged them in, got those values. So again, all I would care about is plotting those 2 points and then making my graph. This is a whole bunch more work. Let's talk about what this next useless line is. What is the sign of each of these? That's a positive. That's a negative. That's a positive. That's a positive. That's negative. That's positive. Just what are the signs of the y values? Got the value, now the signs. Pointless, right? Okay, what does the sign of a y value tell you? It tells you if it's above or below the x-axis, right? If you are a positive y value, you're above the x-axis. If you're a negative y value, you're below. So they want us to write that in for each of these. If you're positive, you would be above. Negative would be below. Positive, above. Positive, above. Below, above. Okay? This is silly to me. Let's graph the points, though. To the left, 3, up 4.4. I'm already done. I know where my other curve is, right? If I have a point right there, I know I'm here. I would have figured that out right here, right? That's what I said I would have had you do to find out what's over there. Okay. -1.5 down -2.3, whatever. It's right here. That still is not telling me if I'm making a curve and going back down or if I'm going to go through the x-axis or the horizontal asymptote. So this is a pointless point in my opinion. Okay. Same with this point. To the left 0.5, sorry, and then up point, wherever that is, that's somewhere in between these 2 points. It's still not giving me enough information. Again, I would not have picked that. But 1, remember we talked about that? 1, 2, this is where I see now what's happening with this graph. And those 2 points are kind of messed up. It's too small. Okay, because I'm going up, I am going to go like that in the middle. The minute I touch that asymptote or I go above it, I know what the middle is going to look like. It kind of looks like an S or a backwards S. So it's either going to look like that or like this in the middle. And it clearly didn't turn around and go the other way. So I would have figured that out right here with the 2 points we talked about that I said we should pick. We don't even need this point. We don't need this point. But that's what all of that was about. And you could go back and look at where the graphs are above the x-axis and below. Who cares? We plot points. It's so much easier. It's just easy. You pick the ones you need, just do that work. We didn't need to do all this work. But I'm supposed to show it to you, showed it to you. Okay? Now, let's talk about what the homework is. Because I gave you one of these in your homework. All I care about, though, in the homework is that you know how to do this stuff. All of this stuff. This is really, really important. You can steal my answers for this if you want to, all right? So just steal them. Go to practice set 1. Practice set 1. There's 3 practice sets because there's 3 days of new material. So find practice set 1. What page is it, guys, if you want to tell me? 92? Thank you. Again, for some reason she hasn't put numbers on my pages. So, okay, so page 92, you're just doing 2 through 8. It's A21. Number 2 is the only one like we just did. And like I just said, I want you to steal my answers. Because it's what number 2 is going to give you down here is the other points you need. I don't want you to have to do all this work. I would like for you to know, okay, the important X values, how did I get those? How did I pick these numbers? I picked in between these. And then I plugged them in, but steal the answers. And that will help finish your graph, okay? But make sure you know how to do all this stuff. And this is written in a different order than we have written it. Don't worry about it. It doesn't matter what order it is. You can still write your whole first, then your VA, then your HA. The order does not matter. Excuse me. Okay, after number 2, and I'll put this back up in a second, just tell you, the rest of this is kind of like an FRQ. Just look up here. This is what we're going to really be doing tomorrow. You're given a graph, and you have to answer some questions about the graph. And then, using that information, you're going to try, I'm giving you the answer obviously, but you're trying to come up with the equation for the graph. Like if I gave you a line in slope-intercept form, you could pull off the M and the B and plug it into the equation and you have the equation. This is times, at a different level, of course. So answering these questions will help you come up with this. It's all about, this is such a great activity right here because it really is going to help you understand all the different parts of the rational function. I will put the key on Canvas and up here if there's time, but I am going to do this one with you tomorrow in class, most parts of it, okay? Because that's really what we're doing tomorrow, is doing a bunch of those. Given a graph, write the equation, okay? But start here, steal this. Steal it, then you can go work on that, okay? You have like 16 minutes. Use it. Yeah. Use it. And again, I would not ask you to do this on a test, okay? But I could see College Board giving you a multiple choice question, which is like, which one of these values would not be a good test number or something? You know what I mean? I don't know. But you wouldn't have to do one of these on the AP exam either, because it would take an hour, for sure. Oh, I didn't mean to say that. It's so much extra work if you just pick values and plug them in. Plot the points, you know if it's above or below, right? Mm-hmm. Like it's too general in my opinion. It's dumb. I would never have taught that to you guys. This is X, Y,